my YouTube channel. So in this video, I'm going to show you how to manually provision a Kubernetes cluster using kubeadm. If you want to follow along with me, I have documented all the required commands and details in my GitHub repo, and I have shared my GitHub repo link in the description below. So let me give my quick introduction. I am Rahees Khan from India. I am certified Kubernetes administrator as well as certified security specialist. So here are my certifications. I'm just going to show you. So this is my certified CKS certification, that is certified Kubernetes security specialist. It is valid for only 2 years. So and another one is mine CKA, that is certified Kubernetes administrator. So to it is valid for 3 years. Okay, and now let's get started with the our Kubernetes cluster provisioning using kubeadm. So I am provisioning my Kubernetes cluster on GCP. So if you want to follow along with me, then you can use your GCP account, but it is required that you have required permissions and rules to provision compute engine. Okay, so let me provision two VMs GCP instances on my GCP free trial account. Okay, uh, okay, prior to that, let me show you my documentation, what I'm going to do and what commands are going to use. So this is my GitHub repo, and here I have documented all the things. So I'm going to provision a cluster with one master and one worker, and I will provide a public IP so that in future you can use your cluster anywhere else. And but yeah, definitely VMs also get allocated a public IP. This IP may differ from your IP, okay, because it is dynamically provisioned. So and the OS is I'm using is Ubuntu 2204 LTS with x86 architecture, and machine type is E2 medium. Yeah, you can use any other as well. It is not mandatory that you use E2 medium only. Okay, in free trial, whatever the version you are comfortable with, machine type you are comfortable, you can use. And I'm going to use default compute engine default service account while I'm provisioning my GCP instances. Okay, and these are the commands that I'm going to use on execute on master and worker nodes. So these are the commands that are common for both the nodes, or you can say master and worker node. Yeah, so and post that there we I'm going to we have to just disable the firewall rule, disable swap, and we have to execute update sysctl settings for Kubernetes networking, and install Docker engine. So I am installing a specific version, that is 20 Docker version 20.10, and similarly we are adding Kubernetes repositories, okay, so that we can download Kubernetes related binaries. Okay, so I am using a specific version of Kubernetes, that is 1.22. Okay, 1.22.2, that is 1.22.2. Okay, and there are few commands that we have to specifically execute on the master. So these are some below. This is the kubeadm init command is used to initialize our Kubernetes cluster on our worker node. Make sure whenever you are executing this command, please don't forget to replace this IP address with your master IP. Okay, I will also later on in the video I will also highlight this point so that you won't face any any issues, okay, any other problems. And this is the command, another command that we have to deploy on Kubernetes master node, and this is for allowing Kubernetes networking. Okay, so I'm using Calico. So there are multiple networking related uh, op- CNIs are, yeah, multiple networking CNI, that is container networking, sorry, CNIs are available: Calico, Flannel, ViVNet. So but I'm using this Calico only. Okay, so and this is a specific version of Calico, that is v333.26.1. And then I will, once these two commands, after execution of these two commands, I will in the inside the kubeadm init itself, I will get a token kubeadm init kubeadm join token command, and token, okay, and then I have to uh, paste that command in the worker node. Once that is done, then we are good with our Kubernetes cluster. So please share, like, subscribe my channel, and please share your comments with me so that I get motivated by your comments and your feedbacks, your valuable feedbacks. So I'm planning to create a entire series for certified Kubernetes administrator. Once that is done, then I will focus on certified Kubernetes security specialist. So really, I appreciate your comments and your valuable feedbacks. So please like, share, subscribe my channel so that I get motivated and create more exciting videos related on Kubernetes and specifically DevOps. But as of now, I'm focusing on the Kubernetes part only. So let me provision two instances on my free tile of GCP account. Okay, I'm going to click on this create instance, and I'm going to name it as kmaster1. Kmaster. Okay, and I'm selecting this E2 machine type as E2. Okay, and E2 medium, that is 2 vCPUs and 1 core and 4 GB of memory. And now we have to select the boot disk. We have to select the Ubuntu, and from Ubuntu we have to use the specific version, that is Ubuntu 22.04 22.04 LTS. Make sure you select this x86 architecture. So I have tested it in this specific version. So, and you can provide this image disk size to 10 GB, but you can go along with the defaults, and you can, I'm just using this default service, compute engine default service account, allow default access, and firewall rules are not required. And you can go with the defaults, and inside the networking options, if I will show you, then inside networking I'm just using the default account, default network. Okay, now I'm just going to directly create the instance. Okay, in the meantime, let me provision another instance for the worker. Okay, worker 1. I'm naming it as 1 because if you want to add more, if you need more nodes inside your cluster, then just you can add another 1 node. Okay, similarly I'm going with the E2 medium, and let's change the boot disk, select Ubuntu, and choose the version, that is x86. Okay, disk size same 10 GB, and allow default access, networking, inside the networking using the default network. Okay, this is the default network. If you have another network, you can also choose, but make sure you have a proper connectivity between your worker and master node. And I'm just going to create it. Okay, let me, I believe my master node get provisioned, let me SSH into it. Okay, yeah, just allow me a minute to get SSH into the machine. And once that is done, I will execute the commands that I have just shown in my GitHub repo. Yeah, authorize it. Yeah, that's, yeah, that's good. Our worker node get also provisioned. Yeah, yes. Now this is our, this now our both the instances get provisioned. This is my master node, and this is my worker node. So prior to that, let me do one thing. Let me note down the IP addresses of both the instances and add to etc host files. etc hosts. Okay, let me fetch out the IP address, IPA. So this is the private IP of your machine. Shift G, pressing the to get to the bottom of the file, append, to append, just pressing O at my screen. So K master, okay, K master and the IP address. Similarly, K worker 1 and its IP. To get it IP, IPA command, and this is 199. Yes, so that's great. Okay, no, sorry, I have to first log in as a root user. Let me copy it. Okay, so sudo su, so I'm just I'm becoming as a root user. Vi etc hosts, pressing shift G to come at the bottom, pressing O to append the content in the file, and save and exit, escape, and then colon WQ. Similarly, I'm sudo su hyphen, okay, and then vi etc hosts. Okay, this in this file we add the entries for our hosts. Shift G, then control O and control V, because I have copied it on my clipboard from the previous file. Okay, save and exit, escape, then colon WQ. Yes, now you can see I have a proper connectivity between my both the nodes, or master and worker node. Let me add K master by the name. Okay, you can see I can see a ping. Look, make sure that you have proper firewall rules in your GCP account if you want to test. So ICMP firewall protocol is used for ping in GCP. So a firewall rule corresponding to it should be available in your, if you are testing like this. And NS lookup, so master K master. Yeah, you can see I'm getting the IP address. Similarly, I'm pinging worker node as well. That's not good. Copied something else. Okay, ping worker node IP is 99. You can see ping is working, and NS lookup K worker 1. Look, I'm getting its corresponding IP. Okay, so so I'm just doing this just to prove that we have a proper connectivity between our both the nodes. Okay, so that we can I'm in the beginning I'm avoiding further issues. Okay, if we don't have proper connectivity, then we might definitely we will face in issues in while we are provisioning our Kubernetes cluster. Okay, so now I'm going to my GitHub repo and just executing the commands. So these are the below are the commands that we have to execute on both worker as well as master node. So this is I have already executed. Now I'm going to disable the firewall rule. Okay, yeah, on the worker node as well. Now disabling the swap, and this is sysctl settings for Kubernetes networking. Okay, now installing Docker engine. So I'm installing a specific version Okay, this is 20.10.20 on as a Docker container runtime engine. Okay, installing Docker. We'll show you the version as well later on once it gets installed properly. Press Y, press yes for the installation. Okay, so next we will go to add Kubernetes repositories. So these are the commands, okay, we have to add. Let me copy it. So it is still in progress, we have to wait a bit more. Yeah, so almost 98%. Yeah, that's done on my master node. Okay, yeah, let me show you the Docker is installed properly. Okay, Docker version. Okay, you can see this is the Docker version 20.10.20 is the Docker version. Yeah, great. Docker version. Okay, this is same 20.1.0.20. now I'm adding these repositories. Added Kubernetes repositories on both the machines. Now this is to install Kubernetes binaries. Okay, so I have copied it. I'm installing a specific version of Kubernetes, that is 1.22.2, and similarly on the master node as well. Yeah, it's cool. Next, this is the command that we have to take care. Inside this API API server advertise address, you have to provide your master node's private IP. Okay, so this is my worker node. I'm going to copy. Let me first fetch my ns lookup. Okay, let me execute IPA command. Okay, so this is my IP address of my private IP address of my worker node, master node. So here, instead of this 15, it is 10.120. Look, I'm following it from here. 10.128.15.198. Okay, make sure you change it. Okay, and let me execute the command. Let me just cross verify, double check on private IP address of master node 10.128.15.198. yeah, allow some time to execute it properly. Stay tuned. I will try to fast forward this video. Okay, so that I can save your time. Yeah, now it is pulling the required images. So inside etc Kubernetes manifest, it stores all the static ports. So I will try to cover all those components in my Kubernetes series. Okay, yeah, that's done. Our command gets executed successfully. So these are the few commands that we have to execute on our worker node itself. Okay, so that we can use our kubectl binary. So kubectl binary is used to interact with our Kubernetes cluster. Okay, so usually we keep it in our on our master node, and I'm also following the same. Okay, yeah, so now we can use our kubectl binary to check kubectl get nodes. Okay, look, this is the our currently status of our cluster. This is the name of the node key master. Status is not ready because still there are few configurations that we have to make. We have to deploy networking. Okay, so I'm deploying a Calico network as a networking plugin for our Kubernetes cluster. We have different networking plugins like Calico, Flannel, VNet, So I'm using this calico. Okay, yes. So we have executed this command as well successfully. Let me execute once again kubectl get nodes. Okay, look, as I executed the deployed the calico networking related resources, Kubernetes resources on my master node, it get become in the ready state. Now to add our work node to our cluster, we have to execute the output of this. We have to execute this command on our worker node. Okay, so I'm going to execute it. Yeah, copy it and just paste it to our this worker node. Look, the output, this node has joined the cluster. So okay, so this is a good indication that we are going in the right direction. kubectl get nodes. Okay, so you can see it will take some time to provision the ports on the worker node as well. Okay, so, and then once they are get provisioned successfully, it will become in the ready state. Okay, let me show you in the there is a namespace that is kube system. Okay, kubectl get namespace. Okay, so this is the kube system namespace where all the resources which are required for to working for the Kubernetes cluster are deployed in this namespace kubectl hyphen. Let me show you all the pods. Okay, kube system get pods. So you can see these are the pods, and if I show you hyphen o wide, then we will get to know that where are they are running. So it is running on k master, k worker. So calico, look, calico is the networking is also deployed on our worker node as well. And yeah, rest are the major components. So 4 major components. Okay, let me stretch it so that you get a better view. Okay, so this is our calico kube controller. It is deployed on our master node because it is a component or a pod that is deployed on master node itself. And similarly, calico is deployed on as a daemon set, and daemon set are deployed on all the nodes available in the Kubernetes cluster. Okay, it is deployed on both master and worker nodes, and this is the DNS which is required, okay, for the DNS purpose, and etcd is only deployed on the Kubernetes master. And similarly, kube API server and kube controller and kube proxy. So kube proxy is also deployed as a daemon set. It is also deployed on the worker node. So now let's check our status once again. kubectl get nodes. Now I believe, yeah, look, great, well done. So this is now deployed. We have deployed a Kubernetes cluster with one master and one node, okay, one worker node. So now you can easily use your Kubernetes cluster for your learning purposes. So yeah, let me quickly deploy a pod or not kubectl a deployment of Nginx. Okay, kubectl create deployment. I'm just naming it as Nginx, Nginx hyphen image is equals to Nginx. And yes, look, it is created a deployment kubectl get all. So by default it uses the default namespace. Look, everything is running. One pod is running in running state, and this is our replica set deployment and the service. So this is the service that is created by Kubernetes for its own purpose. Okay, so yeah, that's all I want to show you in this Kubernetes video, cluster provisioning. So yeah, please like, share, subscribe with your colleagues, and please let me know if you have any issues, any suggestions for me in the comments. Yeah, thanks a lot for watching this video till end. Stay tuned. Please share, subscribe my channel. Thanks a lot. Bye bye.